Second part of lesson 16, relative motion. We're going to move to a more complicated relative motion question. This is a standard of excellence question, and all your exams should have 20% standard of excellence and 80% acceptable standard. When you're at your diploma in grade 12, 20% of the test will be standard of excellence questions. Standard of excellence questions are just higher level thinking questions that are just a little more complicated than your regular question, and they are designed to make you think a little more, think outside the box, so to speak. So we've got a plane. It wants to fly north at 500 kilometers per hour, while the wind is blowing at 100 kilometers per hour, 30 degrees south of west. With what velocity should the plane fly? Two terms that you should know for plane problems: ground velocity and air velocity, or air speed. The air speed is like the boat in still water. So what is your airspeed is the wind is irrelevant. So what speed are you flying in the air if there was no wind, right? And the ground speed, that is essentially the resultant vector. So in this, the velocity with which somebody on the ground would measure. So that's kind of the important one, right? If you're flying to Edmonton, this is not the solution to this question. If you're flying to Edmonton, which is due north, and typically the winds in this part of the world flow from the west to the east, and the wind is blowing this way, well, if you don't adjust the direction of your flight, you're going to end up over here. You're going to miss Edmonton. So obviously the plane points itself in this direction. Then when you add in the wind, you actually get to where you want to go. So this is what we're talking about for this problem. This problem is saying, which way should I fly so that I actually end up 500 kilometers per hour north? And a good diagram is the key. If you draw a good diagram, you can actually solve this problem quite quickly. So we want to go 500 kilometers per hour north. That is the ground velocity. I can't put it out in there. Obviously, that's the wind velocity. And then this, with what velocity should the plane fly? That would be your airspeed. That's what we're trying to calculate. So what happens is, in this question, is that this here is actually the resultant vector. So that's the way that we want to go. We want to go 500 kilometers per hour north. But the wind is blowing, let's just do this separately, 30 degrees south of west. So here, 30 degrees, that's the way the wind is blowing. If the wind is blowing in this direction, and you're going and you want to end up north, which way are you going to have to fly? Think about that in your head before I put the answer on the board. Which way should I point my plane so that when you add the wind in, so when we add my speed, the airspeed, and the wind, I will end up with this. Okay, and you probably figured out, here's the wind. That is the green vector, is the vector that I want to point the airplane so that I end up going, sorry, that red vector is not quite straight, is it? Let's just redraw the whole thing so that it looks straight. So I want to go 500 north. Here's the wind. Here's my airspeed. Now let's look at that diagram. Oh, it's still a little crooked. Oh well, we'll live with it. Let's look at that diagram and notice that the resultant vector, I said that the 500 kilometers per hour is the resultant vector, and it is tail, tail, tip, tip, as all our two-dimensional vector problems are. Okay, so that totally works. Now, and let's just go over this. If I point my plane in that direction and the wind is blowing in that direction, then I end up going to go in that direction. Just simple vector addition Not too tricky at this point. Okay, but once you've got that diagram, then things become much easier. Because what information do we have? Well, we have this vector here is 500 kilometers per hour. We have this vector here is 100. The blue vector is 100, and we also have the angle. So let's, as we'll always do, if we have a vector at an angle, we're going to separate into an x and y component. So let's take the wind. Separate it into an x and y component. And what we get for the x, we're going to use cosine to find x. X equals the cosine of 30 times 100, and we get 87. Y equals the sine of 30 times 100. Oops. And we get 50. Okay. So now, because I've drawn my diagram fairly well, it's actually a little shoddy, but you get the point. Because I've drawn it so that it's going to make a nice right angle triangle right there, I can see that my y component here is 50, right there. My x component up here is 87. Right, and that's the key to this problem right there, is if I've done that correctly so that I can visualize this, I can now see the x and y components of the green vector. The green vector is the one I'm trying to find by air speed. It has an x component, and clearly you can very clearly see that it is 87, because only the wind had an x component. My velocity going north did not have an x component. And we can clearly see now that my y component of the wind is going to be 500 plus 50. 550. All right, I'll give you a couple of seconds to let that soak in. A good diagram is going to be the key to solving a lot of these problems. Now that I've got that, calculating the green is simple. Simple Pythagorean theorem, inverse tangent. Let's just draw it separately because at this point it's getting a little convoluted. So we've got resultant, we've got an easterly component, we've got a northerly component. This one we said was 87, this one is 550, r theta. R equals the square root of 500 squared plus 87 squared, which turns out to be 556 kilometers per hour, which should make sense to you, because if you want to go north and the wind has a southerly component, you're going to have to fly faster than 500. If you want to go north at 500 kilometers an hour, but the wind is pushing you a little bit south, then you're going to have to fly a little faster than 500 kilometers per hour. And theta turns out to be inverse tangent inverse 550. Oh, I don't have the angle. I didn't calculate the angle. Oh, I didn't calculate the angle. Why didn't I calculate the angle? I'll tell you why. Because nope. In this question, it says with what velocity. So I do have to calculate the angle, and unfortunately, I didn't do it. And now I'm going to have to go on to this. Do it on my calculator. Because my other calculator, the battery is dead. Sorry, this will give you a couple of seconds to soak it all in. Do 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 do. Here it is. My calculator, inverse tangent, second function tangent of, what do we say it was? It was 550. 550 divided by 87 in the brackets, and we get 81 degrees, which totally sounds right. It's going to be a very steep angle. Because this is 515, this is 87. It's not a very well drawn triangle. We would get 81 degrees. 81 degrees. And so my final answer to this question is, in order to get 500 kilometers per hour north, I have to fly at 556 kilometers per hour. 556 kilometers per hour, comma, bracket, east, 81 degrees north, or 81 degrees north of east, right? Which makes sense. The wind is blowing in a southwest direction, so I'm going to have to fly in the opposite direction. The opposite of southwest is northeast to counteract that wind. Okay, I hope that problem made sense and you enjoyed it. We'll see you for lesson 17.